We should be just on the back side of this page. And before we even get too far, I'm just going to write at the top the law of sines again. So if you guys want to write this at the top of your page, just so it's there and you can see it so that we kind of know what we're going to be using here. We're going to get into some examples on actually how to use this. So law of sines can be used when you don't have a right triangle. So when you have something without that 90-degree angle in it, but we're still trying to maybe solve for angles or sides. So some of our problems that we have today are going to have multiple things missing that they want us to find. And so we may not just have to find a side. They might want us to find all the sides or find all the angles. And they may even say, solve the triangle. If they're saying solve the triangle, that means they want you to find everything that you could possibly find about that triangle. Find all the angles, find all the side measurements, okay? So on this first one, we have 2 out of the 3 angles. So let's go ahead and just find the first one. How would we do that? Okay, so I'm just going to write that next to it here, 180, and I'm going to subtract the 45 plus 106, adding those together, subtracting that from 180. And what does that give me? Okay, now because we found it, I'm going to go ahead and put it in my picture as well. It's now free for me to use. Like if I feel like it would be beneficial for me to use that angle, then I would, okay? Now I have one of the sides. I see that the side across from big C, so they call that little c down here, just because we talked about how those kind of connect, is 25. I'm going to have to use law of sines now to help me find the other sides. So let's think about down below they have little a and little b. Let's think about where those would be at on our picture. So little a would be across from big A. So I'm going to just mark my picture. This is where the A side is. And then little b would be across from angle B. So that's how I would label it, like that. And now let's think about how we could use law of sines here. Now I would suggest when you're using law of sines that you always try to figure out a side and an angle that you for sure know are directly across each other and use that. So because the C is given to you and the side C, I would use the 106 and the 25. So I'm going to go ahead and just write that sine of 106 over 25. Okay, we're going to set this up to another equation. Now, do you guys want to solve for little a or for little b first? A. So what's the angle that's across from A? 29. So we have to use the 29. You have to keep the little side with the angle that it's across from when you're using law of sines. I can't just use the 45 and then solve for A. That they don't have a connection in the law of sines like the other ones do. So I would write sine of 29, and then A would go on the bottom like this. Now really what you just set up there is a proportion. So in the past when we solved proportions, what did we do? We cross multiply. Okay, so on my calculator, or how I would maybe write that out, is going to say 25 times the sine of 29 is equal to A times the sine of 106. How would you guys get A by itself? Okay, divide the sine of 106. Okay, so these are gone over here. So I'm just going to cross them off. Now at this point, you're going to have to rely on your calculator. Okay, so if you didn't grab a calculator when you walked in, I'd go get one really quick because I'm going to kind of talk you through how I would type this in. So I would really encourage everyone has a calculator in front of them so that you can practice typing it in. You want to make sure you're getting the right answers. When you do this, you don't have to type it all in at one time. I mean, you can, but if you're afraid of making mistakes or you don't want to have to take too much at one time, split it into smaller pieces. So if you're just figuring it out and just beginning, what I would suggest you guys do is take 25 times the sine of 29. You guys know how to type something like that in because that's what you had to do in the last unit when we were solving for sides on triangles. So you should be able to do 25 times the sine of 29. Make sure you close your parentheses, okay? Once you get that answer, then you can just divide it by the sine of 106. Now you're probably going to get a decimal for an answer here, so let's round our answers to the nearest tenth today for our side measurements. So what did you guys get on your calculator for A? 12.6. Did everyone get 12.6? If you're not getting 12.6, let me know because I can come look and see how you're typing it in. But that's what I have written down for A. So I'm going to go ahead and write 12.6 over here. And they do provide me a label on the triangle. They're saying that that side C was 25 centimeters. So I'm going to go ahead and just say centimeters here as well. Okay, so that took care of A. We also, though, still need to set it up to solve for B. So let's set up another law of sines for my B. What could I do for this one?
Sine of 106 over sine of 25 equals sine of 45 over b.
Good. Everything about that looks the same as what we did up above. It's just I'm using the B side instead, so I have to use the 45 degrees. We solve it the same way. Cross multiply. So you're going to have B times the sine of 106 is equal to 25 times the sine of 45. What would we need to divide by? I wrote it backwards this time. Sine of 106. So that's gone. And then again, we're going back to our calculator. So for this one, you're taking 25 times the sine of 45 all over sine of 106. It looks very similar to what we had up here. It's just my sine on the top is the other angle because I'm switching to a different side. Okay, again, let's round that to the nearest tenth. What'd you guys get for this one?
18.4.
Point what?
I got 18.2.
Point two. If it's like off a little bit, it could just be the way that your calculator is rounding, like in an earlier operation. As long as you're fairly close, I'm going to call it good. So if you had 18.2 on yours, 18.4, those are fairly close to each other. Especially when you're solving for sides like this, there's going to be decimals here when you have a lot of sines and cosines showing up. But if you had something like 20, that would probably be more of like a reason for concern. Okay. All right. So that's your first problem using law of sines. How do we feel about it? Fun? Oh, fine. Fine. Everyone understand how we set that up and we're typing in our calculators? Okay, so let's go on to the next one here. Okay, similar to that last one, they want me to find angle A. I would maybe start there first. You know that the other two angles are 57 and 64. So what should we do to find angle A? Okay. So what is that? Good. And then I'm going to go ahead and put that in my triangle as well. Okay, now we're kind of back to our sides. On my triangle here, where should I put like a little b and the little c? Because that's what they're wanting me to find down below. On the bottom should be what? Little c. So like in between A and B, you're saying? There should be little c? So then little b has to come over there because it's got to be across from big B. Okay, I'm going to give you guys some time, a couple minutes here. I want you to go ahead and try to set up your law of sines.
So C always has to be like across from it?
Yes. So that big C and little c always need to be across, and big B and little b always need to be across each other.
Yeah.
Yep. Okay, so I'm gonna give you a couple minutes. I want you guys to try to set up 2 separate law of sines and see if you can figure out how much those sides are. All right, why don't you guys take the next like minute and a half here, talk at your table groups, see if you guys got the same answers for those sides. If someone doesn't have that answer, see if you can maybe help them figure out where they got stuck, or maybe if you guys disagree, figure out who's right, who's wrong. Okay, so take a minute and a half to do that. All right, someone want to walk me through, if they feel confident about their answer, how you got little b?
The sine of 59 over 9 equals the sine of 57 over 3.
Everyone agree with how she set that up? Okay, you have the 59 and the 9, so like those need to go together. Okay, because that's the opposite angle, opposite side. And then sine of 57, that's going to go with your little b, because those are opposite of each other. What did you do next, Greer?
Cross multiply. We got 9 9 times the sine of 57 equals 9 times the sine of 59.
Okay, good. And then what did you do?
Divided by the sine of 59 on both sides.
Okay, so these are gone over here. So B is going to be 9 times the sine of 57, and then you're dividing by the sine of 59. What did you get for that, Greer?
8.8.
8.8, and then it would be centimeters, right?
Yeah.
Okay, perfect. I agree. All right, somebody else walk me through what you did to find little c. Do you mean sine of 59 over 9?
Yeah.
Okay, equals what?
Sine of 64 over 6.
Everyone agree with Solomon there? It's very similar to what we were using on the last one. We're just now switching to big C and little c. What'd you do next, Solomon?
9 times sine of 64 equals sine times sine 59.
Good. And then what?
Divide sine 59 by both sides.
Okay, so on your calculator here, then you guys should have been taking 9 times the sine of 64, dividing all of that by the sine of 59. And what did you get, Solomon? 9.4 centimeters again. Okay. Don't try to go too fast through these problems. It's really easy to make a mistake, especially if you accidentally misread the triangle or you grab the wrong angle or you grab the wrong side or something. So take your time on those. And also when it gets down to actually typing it into your calculator, like I said, break that into pieces if you need to. There is a way, like you could use the fraction, the N over D button on, like my calculators will give you a fraction setup. You can put this on the top and put this on the bottom. You got to make sure you're closing parentheses. If you don't close your parentheses, your calculator will not read it correctly. Okay, I always tell students your calculator is only as smart as the person working it. Calculators can do a lot of cool things, but if you don't know how to type it in, it will not give you the right answer, okay? Because a calculator doesn't understand order of operations. It doesn't know what you mean for it to do. So you have to be really explicit on how you type it in. So make sure that you're taking your time through that. If you're not getting these answers that I'm getting today, you need to let me know. And I can come talk to you one-on-one, kind of watch you type something in and see if there's something that you're missing or something that we need to fix on your calculator. Okay? All right, we've got one more here on this page. But if we look at this one, do they give you a triangle? No, so we need to draw one. So let's go ahead and do that. It doesn't really matter what your triangle looks like. And it doesn't really matter where you put A, B, and C. I'm just making mine look like that, okay? But now they are providing us with some information. We need to add that detail to our picture here. So where should I put the 47 degrees? Okay, next to the A angle. What else can I add to my picture? Where would side A be at? Across from angle A, so in between B and C, right? So this would be 20 centimeters. Where should the 12 go? Good. Okay, what do you need to find this time? 2 angles and 1 side. Okay, we've not had a problem like this before. There's no direct way to find those angles. I can't just subtract from 180. I could take 47 minus 180, but I have no idea how B and C are being split. So we're going to have to still use law of sines, but on this one, you're going to be missing an angle. Okay? Now, I would have to use the 47 degrees and the 20 because those are going to be paired up together regardless. So they're going to be useful for me when I'm setting this up. So let's figure out how we're going to do this. I'm going to use this 47 and 20. So I'm going to write sine of 47 over 20. Those are partnered up for life, okay? They have to always stay together. Now I need to figure out on the other side, I need to find one of my angles. I can't find the other side until I have at least one more angle here. What other side besides the 20 do they give us information for? Side C. So that means I should probably try to find angle C because they have to connect. So for my next one, I'm going to write sine of C over 12. So the setup is the same. Our variable's in the wrong spot though, or in a different spot, I should say. How would you guys begin to solve this? We're still going to cross multiply. So 12 times the sine of 47 equals 20 times the sine of C. Now my variable is in that sine of C term, so I want to get that piece by itself. How do I move that 20 away from it? I got to divide by 20. Okay, you guys still all have calculators, yeah? So if you type in that left-hand side, 12 times sine of 47, and you divide it by 20, do you get a really weird decimal? Does it seem maybe kind of odd? What are we looking for here? We're looking for an angle. So you get this weird decimal. It's really small, and it doesn't make sense for it to be an angle measurement. What do we need to do to that to get the angle? We don't want to multiply or divide by sine, but we want to use something with the sine. The inverse, okay? Second sine, right? Because we're finding an angle. Now you could have done that to begin with, but you'd have to really be savvy with how to use your calculator. You can hit your second sine, type this in as a fraction in there, okay? But you got to be pretty confident in your abilities to work that calculator. If you don't really want to do that, get that decimal, okay? And then you can hit second sine. And if you want to keep that whole decimal, here's how you do it. So if you guys hit second sine, hit your second button again, and then hit this button right next to the enter sign. That's like where the negative is at, because right above it, it says ANS. That stands for answer. So it's going to take your last calculated answer, and it's going to pop it in there for you. So you don't have to type that decimal in if you don't want to. If you round the decimal and type it in, you'll get an answer close to what we get, but it might be off by just a tish. Okay, what are you guys getting?
26.
Whoa, what? 29? 26? 26? Is 26 the majority? I have 26 written down. Let me see. Did you round your decimal when you typed it in?
No.
No?
Oh, sorry.
Yeah, just show me what you have.
47.
Oh, hold on. You gotta close your parentheses here first before you do the division, or else it will not read it right. So this is your decimal. Then you hit second sine. Who else got 20, whatever, not 26? Did someone else get that? You got it figured out? Okay. All right. So now that we know this is 26, how do you guys find B? Yeah, and I would probably round your angles to like whole numbers like that so that you're dealing with whole numbers on the angle side. So yeah, we're going to add 26 and 47, and we're going to subtract that from 180 now. And what does that leave me with? 107. So that's here. We got one last thing to find. Side B. Okay, I'm probably going to go back to law of sines, but what would this one maybe look like?
Sine of 47 over 20 equals sine of 26 over 8.
I don't think 26.
Oh, sorry, 107.
Yeah, 107. Now we're back to what we started with.
Do we always start with sine A?
You don't always start with sine A. No. Sometimes they'll give you, it just happens on a lot of, well, like the first one that we had, the very first example, we started with sine of angle C over little c.
Does it matter? Like, is it ideal to use sine A? Because that's what we've been starting for these two. So I don't know.
The last two we did only because they gave me, I had the angle and the side for my A's. It doesn't really matter which one you start with. You just need to use two of them. So if you're using the A's, if you can, great. If you can't though, it's okay to start with B or to start with C. It's also okay if you wrote that opposite. Like if you said sine of 107 over B equals sine of 47 over 20, you're going to get the same answer at the very end because the math all comes out to be the same. Okay, that's a good question. All right, if we multiply, cross multiplication here, we'd have b times the sine of 47 equals 20 times the sine of 107. What do I need to do to finish this off? Divide by,
Sine 47.
okay. What do you get? If we round it to the nearest tenth.
26.
Point, or is it just 26?
It's 26.
26, but you can do 26.2.
CM. Okay. Questions on law of sines, guys? All right, we do have a worksheet for you to kind of practice this formula. So we're going to get that out to you